All right, let's see what skills we need to review for our test on Wednesday, starting with the vertex of this graph. It's right at that turning point at the top of the graph. That's the coordinate point, -1, 8. Our axis of symmetry is that imaginary line that goes through the vertex. It's a vertical line that goes down the middle of the parabola. We've got a mirror image on both sides. We write that as the equation, x equals -1. It is an equation of a vertical line. That's why we have x equals, and you'll notice that that -1 matches from the vertex. Our y-intercept, you know that one. It's where it crosses the y-axis. In this case, that's the coordinate point 0, 6. And the x-intercepts, where we cross the x-axis, we have 2 points this time, the point 1, 0, and the point -3, 0. Make sure you're writing these as coordinate points because 0, 6 and 1, 0, it's an important distinction there. Remember that domain refers to the x values covered by the graph, and in this case, our graph extends to the left forever and to the right forever. We've got arrows at the bottom of our graph there. Goes to -infinity to positive infinity, meaning our domain is all real numbers. Our range is not all real numbers because our graph doesn't go up and down forever. Instead, it stops, its highest value is 8, and it extends downward forever, meaning that our range is the y values less than or equal to 8. All of the y values below 8 are included. Now, for the equation, we had a lot of trouble with this the first time around, so let's make sure we're paying close attention. Since we've got the vertex form of our equation is probably going to be a good friend of ours here. Remember, y is equal to a times x minus h squared plus k. And since we know our vertex is -1, 8, I'm going to replace that in my equation. So that means y is equal to, and then inside the parentheses, I've got x plus 1 squared plus 8 at the end. So I've included my vertex. I'm using an x plus 1 inside the parentheses because it's the opposite of that -1. Now, in order to help me solve for a, I'm going to use a different point other than the vertex to replace x and y. And I think I'm going to use the point 1, 0 as my x and y value because it's pretty straightforward to work with. So I replace y with 0 and x with 1. So my new equation only has an a value that's unknown in it. So from here, even though it's going to require a little bit of mathematical operations, order of operations, we can figure out what that missing a value is. So starting inside the parentheses, 1 plus 1 is 2, 2 squared is 4, so our equation can simplify to 4a plus 8 on the right-hand side. And then from here, solving for a, subtracting 8 from both sides, that's -8 is equal to 4a, and dividing both sides by 4 means that a is equal to -2. That negative makes sense because our graph is concave down, and we get our full equation, y is equal to -2, x plus 1 squared plus 8. So all those key features that you know by now, I think the hardest part of this particular question was writing that equation. If I was making this note card, I would maybe write out that process, or at the very minimum, write that equation, that vertex form equation, on my note card somewhere. Next, graphing a function. This one is written in standard form. We're graphing the function y is equal to -x squared minus 6x minus 8. Starting with the axis of symmetry. We know the axis of symmetry is the x value of the vertex. So we start with the formula. X is equal to -b over 2a. Again, if I'm thinking about my note card, that's probably going to be a good formula to include. So our a and b values come directly from our equation. A is -1, b is -6, and c is -8. So I'm going to substitute b with -6, being very careful of that negative sign, and a with -1. So when I simplify that, our numerator is 6, our numerator is -2, and I get an x value of -3. So my axis of symmetry is x equals -3. Next, my vertex. Well, I've already got half the vertex. I know my x-coordinate is -1. Now I just need to find the y-coordinate by substituting -1 back, oops, not -1, -3, substituting -3 back into that equation. So y is equal to negative, out in front, -3 squared minus 6 times -3 minus 8. Now, if I'm using my calculator to figure this out, I'm going to have to type this in exactly as it's written, parentheses and all, because otherwise that order of operations is going to be the main effect with the calculator. It's not going to know what you mean if you just expect it to read your mind. So when we do that, we eventually get a y value of 1. So our vertex is the coordinate point, -3, 1. And if I wanted to graph that on my graph, I could do so, -3, 1. Next, the y-intercept. So I could either find the y-intercept by replacing x with 0 and figuring out what y is, or knowing that this is a standard form equation, I can just look for my c value. In this case, I know that my c value is -8, making my y-intercept the point 0, -8. No calculations necessary, but if that's something I have a hard time remembering, you know from previous experience, you can always find the y value or the y-intercept that way. Now, since I have my axis of symmetry, my vertex, and my y-intercept, I could mirror my y-intercept on the other side of that axis of symmetry and get the free point, -6, -8. Now, I do need some points in between there. I need 5 total points, right? 5 accurate points for my graph. So if I'm thinking about other x values to use, -2, -4, or -1 or -5, those are going to be x values that are probably going to be helpful for me. So I might just include a couple of those, -2, -1, so I can see what else is going on. So when I replace -2 in there, that's -2 squared minus 6 times -2 minus 8. And for -1, same thing. Again, I'm going to end up with 7 total points. You only need 5, but more points is not going to hurt you here. So in my calculator, if I do this correctly, I'm going to get -4 plus 12 minus 8, which is 0 for my y value when x is -2, and when x is -1, I'm going to get an x value, or a y value, excuse me, of -3. So I know those 2 coordinate points, and I know the free coordinate points, their mirror image. So I can graph that. I also happened to find my x-intercepts in that process, the coordinate points -2, 0, and -4, 0. My domain here is all real numbers. It's always all real numbers. And my range, because my graph hits a maximum at a y value of 1 and only goes below it, my range is the y is less than or equal to, not -1, +1. Excuse me there. So standard form. Knowing that vertex makes this the same process as when you were graphing with the vertex formula. Find the vertex, make a table of values, make your graph. We can see that in action here with vertex form. Again, on my note card, I might want to write down the difference between vertex form and standard form. So with vertex form, I have the vertex embedded within the point, or within the formula, excuse me. So this is -4, -8 is my vertex. I also get my axis as symmetry. It's the same x value as the vertex. Now my y-intercept is not -8. My y-intercept is not automatically given to me here. So I probably need to go back and find it. So I'm going to plot the vertex here just to see that, -4, -8. And now I'm going to go and find some values to put in my table. So that's 1/2 x plus 4 squared minus 8. So if my vertex is at -4, I'm going to put some points around it here. Now, since this is 1/2, I know that it's going to be kind of a wider graph, and I'm actually going to spread out my x values a little bit. If I were to just go by 1s, that would be perfectly fine. I'm going to go by 2s though, because I know that this is going to be a wider graph, and that might give me a better idea of what the rest of the features look like the y-intercept, like the x-intercepts. So plugging those in, that's 1/2 times -2 plus 4 squared minus 8. Again, if you use your calculator, you're going to be just fine as long as you're using your calculator correctly. If we use our calculator incorrectly, we're going to have a bad time. So you can do this the old-fashioned way with the order of operations. Not going to hurt, just a little bit more work. So 1/2 of 16 is 8. That's 8, that is 0. So you can always double check my work there with those calculations, but you could follow along with my points. I've got -2, -6. Oops, I plotted my vertex in the wrong spot. Make sure that's in the right spot there. -2, -6, 0, 0, and -8. Whoops, 0. Graph with precision. So just expanding that made it, gave me more information about the graph, like the fact that my y-intercept is 0, 0, and my x-intercepts are the points -8, 0, and 0, 0. My domain, of course, is all real numbers. And this time, since my range goes from -8 and above, y is greater than or equal to -8. So again, starting with that vertex, using it to make a table of values, and using that table of values to make a graph. Solving by factoring. Solving by factoring here. If you are having trouble factoring, you need to go back and review that before Wednesday. There are videos on our module page. The key here is that our equation must equal 0. It has to be set equal to 0 in order for the factoring process to work, because we're going to use the zero product property, and the zero product property doesn't work with any other number. So starting with part A, -4x squared plus 32x equals 0. This is a binomial, not a trinomial, and I'm noticing that -4 and 32 both share a 4 in common. So if I factor out a 4 and an x, squared and x both share an x in common, then my remainder answers the question, what would I multiply by to get back to the original? So -4x times -1x gets us back to -4x squared, and 4x times a +8 gets us to 32x. So now I've got two pieces, two items being multiplied together whose product is equal to 0. So I write 4x is equal to 0 and -1x plus 8 is equal to 0. Two solutions here. I've got two equations, and that's how I get my two solutions. From here, solving using inverse operations, I get x equals 4, and on the other side, subtracting 8, negative 1x is equal to negative 8. So x must be equal to positive 8. My two solutions, x equals 0, x equals 8. Two solutions from those two parts there. Zero product property making all the difference for us. In part B, I've got a trinomial. No GCF other than 1, so I need to start with our trinomial factoring process. What's A going to be? What's B going to be? What's C going to be? A here is 1, B is negative 16, and C is 64. So to factor this into a binomial product, I've got to multiply A times C, which in this case, 1 times 64 is 64. I need two numbers that multiply to 64 and add up to negative 16. That B value, right? If B is negative 16, that's what we want it to add up to. So turns out those two numbers I'm looking for, negative 8 times negative 8 makes a positive 64, and negative 8 plus negative 8 makes a negative 16. So found my two values. I'm ready to rewrite my trinomial. I'm going to zoom in just a little bit. So I get x squared minus 8x minus 8x plus 64 is equal to 0. That equal to 0 is just hanging out. We're not quite ready to use it. Splitting this in half, factoring by grouping requires us to look at the GCF of both halves. So between x squared and negative 8x, my GCF is x, leaving behind a remainder of x minus 8. X times x is x squared. X times negative 8 is negative 8x. I know that in my other half, I need a remainder of x minus 8. I can erase that, little buddy. X minus 8. So the number that I have to factor out is a negative 8. Negative 8 times x makes negative 8x, and negative 8 times negative 8 makes a positive 64. So my factors are x minus 8 times x minus 8, and that is set equal to 0. Now, since this is a product of binomials, I could easily set both of them equal to 0 and solve for x. I could also notice that I've got the same binomial here. So setting one of them equal to 0 is the same as setting the other one equal to 0. And so in both instances, I get x equals 8. Remember, it's okay to have one solution instead of two here. That means that we've got one x-intercept. This is where a parabola just touches the x-axis and bounces back in the other direction. So one solution there, totally fine. Part C, again, we've got a trinomial. Luckily, we're already set equal to 0. That's exactly what we want. So we start with A equals 1, B equals negative 3, and C equals negative 70. And we are ready to go. A times C is negative 70. So we need two numbers that multiply to negative 70 and that add up to our B value of negative 3. And so in this case, those two numbers that we're thinking of are going to be negative 10 plus 7 make negative 3, and negative 10 times a positive 7 make a negative 70. So ready to factor x squared minus 10x plus 7x minus 70 is equal to 0. Splitting this in half, our GCF of x squared and negative 10x is an x, leaving behind x minus 10. And between 7x and negative 70, we factor out a positive 7 so that we leave behind an x minus 10 again. So our factors are x minus 10 times x plus 7 is equal to 0. So once again, I've got my product of binomials equal to 0. Zero product property says all I have to do is solve for 0. Now, if you are not doing this step where you are writing out that it's an equation set equal to 0, you may make the mistake of writing an incorrect answer, because this process of solving for 0 doesn't mean that x is equal to negative 10. Just because it says x minus 10 doesn't mean that x is equal to negative 10. That process of solving actually shows that x is equal to positive 10. On the other hand, x plus 7 doesn't mean the answer is x equals 7. When we actually do this process, subtracting 7 from both sides, x is equal to negative 7. So don't make that mistake when it's easy to avoid. One more question, solving by factoring. This one is not set equal to 0, so we have to start there. And the way we're going to do that is we're going to move that negative x and that plus 10 to the left-hand side by adding an x to both sides and subtracting a 10 from both sides. Now, none of these are like terms, which means that on the left-hand side, nothing's going to be combined. We're just going to have 3x squared plus x minus 10. And on the right-hand side, we have that 0 that we're looking for. Now, this is the trinomial that we're going to factor using our factoring strategies with a, b, and c. Now we can see our a value is 3, our b value is 1, our c value is negative 10. In this case, when we multiply a times c, we get negative 30. 3 times negative 10 is negative 30. So we need two values that multiply to negative 30 and add up to 1. Again, our b value is 1. And those two numbers in this case are going to be negative 5 and 6. Add up to 1, negative 5 and 6, multiply to negative 30. So 3x squared minus 5x plus 6x minus 10 are equal to 0. Again, that process of grouping, factoring two terms at a time using the greatest common factor. We factor out an x and we're left behind with 3x minus 5. And in this case, we factor out a positive 2 and we're left with 3x minus 5. 2 times 3x is 6x. 2 times negative 5 is negative 10. So we have 3x minus 5 times x plus 2 is equal to 0. So we're in a good spot. We've got our two binomials. The product of them makes 0. So 3x minus 5 said equal to 0 and x plus 2 said equal to 0. I'm going to start there because it's not going to be quite as much work. All I have to do is subtract 2 from both sides. If I can erase that positive sign. Oh, subtracting 2 from both sides. So we get x is equal to negative 2 as one solution. And in our other equation, when we add 5, inverse operations here, right? We're trying to get the x isolated all by itself. So those inverse operations you've been using for years still apply here. We get the fraction 5/3, and by now we know we don't need to be afraid of fractions. We can just write x equals 5/3 and x equals negative 2. Now, if I'm doing this process and I have a little bit of extra time before I turn in my test, I would go back and plug in my x values into my original equation and evaluate and make sure that what I get is a true statement. Just like you checked equations before, you can always do the same thing here. So let's keep going. Got only a couple other skills to look at here. Solving equations for x, this time using the square root principle. There's no factoring to be done here. The square root principle allows us to do this with minimal work. The way we undo that square is by taking the square root of both sides. Important thing to keep in mind here is that there are always two square roots. When I plug in the square root of 196 into my calculator, I get 14, but the algebra student in me knows that there is a positive and a negative square root to every single number. In part B, to get x squared by itself, I can't take the square root yet. It has to be x squared all by itself there. I get x squared is equal to 169. And when I take that square root, I get x is equal to positive and negative 13. It's the square root of 169. In part C, I'm not quite ready to take the square root yet, because we still have an 11 over there. That's 11 times x squared. The opposite of that is dividing both sides by 11. That gives me x squared is equal to 16. When I take the square root of both sides, I get x is equal to positive and negative 4. Part D, a couple more steps, requires a little bit more work. So first thing, we still have to get x squared all by itself, starting with adding 31 to both sides. Whoops, totally wrote the wrong thing there. Plus 31, that's what I meant to say. Okay, so 3x, not 3x squared. I'm going to have a hard time with this one, guys. You're going to have to check my work. 6x squared is equal to, when we add 31 to 281, we get 312. Then we're going to divide both sides by, not by 2. Like I said, you're going to have to check my work here. Divide both sides by 6. And we get x squared is equal to 52. Now, if you're worried here because you know that 52 doesn't have a whole number square root, remember, that's okay. We can write our answer in one of two ways. We could say that x is equal to plus or minus the square root of 52. That would be perfectly accurate and reflect the fact that we're taking the square root. Or we can actually take that square root there and round it to 3 decimal places. So x is equal to plus or minus 7.211. Both of those would be appropriate answers in this case. In part E, we've got a lot more stuff inside that square now, but nothing's moving in, nothing's moving out because of that square. So I know the opposite of squaring something is taking the square root, but this is where a lot of us got in trouble last time. We know that that cancels, that's why we did it. So we're left with 2x plus 5 on the left-hand side. But what does that equal? Well, the square root of 9 has two answers, 3 and negative 3. So we have to consider both of those options here when we're setting up our equation. So we end up with two equations from here. We're taking one equation, and because there's two possible options, we end up with two equations. So plus 5, is equal to negative 3. So we take those two possible options and we write two equations, and then we can solve for x from there. So same process, inverse operations. We get x is equal to negative 1 for one answer. And over here, when we use our inverse operations, we get x is equal to negative 4. So that step, that square rooting is not at the very end like in all of our other questions, and that's where a lot of people got stuck last time or made a mistake last time. So be careful, make sure you're paying attention to that. Same thing in part F, we notice that our perfect square is more than just x squared, it's x plus 4 squared. So we've got to get that all by itself, add 47 to both sides. So we get x plus 4 squared is equal to 36. From here, taking the square root, yes, we get x plus 4 all by itself, broken out of that little square prison, but 36 has two square roots again, 6 and negative 6, and we have to address both options here. It's like we're covering all of our bases. What if it was equal to 6? What if it was equal to negative 6? From here, solving for x in each equation is pretty straightforward. Subtracting 4 from both sides on both equations. In one of them, we get x is equal to 2, and on the other one, we get x is equal to negative 10. Again, just like I could in the other ones, if I wanted to check my work, I could replace x with 2 and x with negative 10 and evaluate and make sure I've done this right. Number 6 is a little bit different than anything we've looked at, but it's important to address all these skills. So we've got the equation y is equal to -2 times x minus 13 squared plus 98. It says find the missing values and round each answer to the nearest hundredth. So part A says if x is equal to 5, y is equal to what? So we're going to take that x value and we're going to plug it into the equation. Y is equal to -2. Instead of x, we're going to put 5 and see what we get. That's what this question is asking us to figure out. So if I'm good with my calculator, I can type this in exactly as it's written. If I want to do this the old-fashioned way using the order of operations, I absolutely can, starting with simplifying the parentheses there. That squared is applied only to that -8, not the -2. So this is -2 times 64. -8 squared is 64. -2 times 64 is negative 128. So -128 plus 98 is equal to 30. So we get a y value of 30. So that one was asking us just replace x with 5 and see what you get for the y value. Part B, on the other hand, says find the solutions or find when y is equal to 0. So if our equation is y is equal to -2x minus 13 squared plus 98, we're going to replace that y with 0. So we have -2x minus 13 squared plus 98. So this question looks exactly like the questions up above here. We're trying to isolate x minus 13 squared so we can eventually take the square root. So subtracting 98 from both sides, we get -98 is equal to -2 times x minus 13 squared. Almost there, we have to divide both sides by -2. So we get, that's -2, because we get a positive 49 is equal to x minus 13 squared. And so when we take the square root here, 49 has two square roots, 7 and -7, and we're going to use both of them. So 7 is equal to x minus 13, and -7 is equal to x minus 13. Solving for x, adding 13 to both sides in both equations, I get 20 as one x value and 6 as the other. So up above, I'm going to write x equals 20 and x equals 6. Two possible options there. The last one in this part, instead of replacing y with 0, we're going to replace y with 15. So 15 is equal to -2 times x minus 13 squared. Got to change that to a minus sign if my eraser will allow me. Almost there, almost there. It knew we were getting close to being done. Let's see, plus 98. So I've got a 15 there hidden behind that nice white box. But again, we're trying to isolate this perfect square term so we can use that square root. If we subtract 98 from both sides, or do our very best to, we get -83 is equal to -2 times x minus 13 squared. And when we divide both sides by -2, -83 divided by 2 is 41.5, positive 41.5. So we know we have to take the square root at this point, and maybe some of you are worried, well, 41.5 doesn't have a nice square root. You're right, it doesn't. But we can estimate, we can round our answers here. So we're still going to take the square root of 41.5. We're still going to get two answers. We're going to get positive 6.442, and we're going to get negative 6.442. Otherwise, our work is still the same. We're still solving for x using inverse operations. We're just dealing with the decimal. No big deal. So we get two answers. We get 19.442 is equal to our x value. And let's see, I add 13 to that. I get not 7, my mistake. I get 6.558 if I'm rounding to the nearest thousandth, although the instructions say round to the nearest hundredth. So we can do that when we write our answer up here. We can say x equals 19.44 and x equals 6.56. So if you've got a good handle on all these skills, that's awesome. You're ready for the test on Wednesday. If not, you know what you need to prepare for the best. You know where you need to ask questions. You know what you need to add to your note card. I will see you tomorrow.